All right, to start today's lesson, we will go ahead and we'll go ahead and do a very quick example, something that we did earlier in this unit. So we look at this equation right here. Okay, this is a y equals to x squared plus 2x minus 8. Now, whenever we see something like this, we are going to contemplate with the possibility of factoring. Okay, we're gonna think about factoring. So we think about, is this factorable? And we always want to wonder that it is factorable. I mean, it means if it's not, then we can do something else. But factoring would always be the first option. And we think about this, we think about two numbers that could get us to -8 by multiplying. And then the same two numbers could get us to +2 by adding. I think we have a number, or we have a pair of numbers that could get us there. That's this. Okay, so we say, hey, we have a root form. Okay, so this is the root form of the quadratic equation. Okay, and and then we say, hey, what are the roots? Okay, well, we call this the root form because we can tell the roots right away, and we can do that by setting the y equal to 0. Okay, and we say, hey, let's go ahead and set the y equal to 0. Okay, and we can solve for x, and again, the meaning of solve means to find the value or values that would make this statement true. So we say, well, to make this statement true, one of the two parentheses must be 0. Okay, so x plus 4 could be 0, or x minus 2 could be 0. So x is equal to -4 and x is equal to 2. So we have these two roots, and we have these two roots right there. And because we know the roots, we can go ahead and plot it and sketch it on the graph. Okay, so we have these two x-intercepts. All right, now, so x-intercepts and the roots, they are closely related. They're not exactly the same thing. Okay, we will say the roots are 2 and -4, but when we present our x-intercepts, we have to say it is 2 comma 0 and -4 comma 0. So they are closely related, but they are not exactly the same thing. Now, then we have a couple of things to look at. We say, hey, can you find out the vertex? Hey, can you find out the axis of symmetry? Now, these kind of information, it's not readily available, but you can figure out. Okay, well, how? How can you figure out? Well, the axis of symmetry is something that we could figure out very easily if we can visualize the graph. And one thing that we know about the axis of symmetry is the quadratic equations are always, symmetrical, left and right. And the axis of symmetry, it's always right in between the two roots, okay? The axis of symmetry is always right in between the two roots. So we can go ahead and find out the midpoint, okay? The midpoint between the two roots. In this case, the midpoint between -4 and 2, it's -1, okay? And we say, hey, that it's -1 right there. Okay, that's easy. And another thing we also know it's that yeah, the vertex, right? The vertex is always on the axis of symmetry. So that means we know something about the vertex already. We know that the x is equal to -1. How wonderful, right? How wonderful. So to get the y value of the vertex, we can simply well, we have an equation, don't we? Okay, so we can just go ahead and say, hey, what's the y value of vertex? The y value of vertex is to simply plug in the -1, and then you can get it. All right. And then we say, yeah, wait, hold on. Nope, something's wrong. Nope, yes. Right here, it's supposed to be 1 only. Okay, so 1 minus 2 minus 8. So you have 1 minus 10, which is -9. So right here, it's -9. And -9 right there. Hey, we got the vertex. Great. Okay, what about the y-intercept? Y-intercept, it's always 0 comma something, right? So you would just go ahead, put in 0 for the x, and then you would get, ooh, that's 0, that is 0. So you have just y equals to -8. So your y-intercept, it's going to be right here at -8. And now we can go ahead and sketch this graph. Okay, we can go ahead and sketch this graph. And that's it. That's how we sketch it based on the root form, something that we did earlier in this unit. So I just want to bring it back. And what we're about to do today is that, as you see the title, we are graphing with standard form. Okay, so in a moment, we'll talk about standard form, but to recap, all right, to recap what we did just now, I want to spend a moment to summarize what you should know about the root form at this point. Okay, now the root form, as it says, you've got the roots. Okay, so we can tell the roots, and this could be a very important slide that you want to screenshot this or take a look at it, uh, just to retain the information. We have the roots. They are the R1 and R2. Okay, so this is a very important information, the roots. And if you know the roots, that means you also know the x-intercept. That's also very important. Okay, what else do we know? Well, okay, we have the a value, right? So the a value is to tell us whether it's opening up or opening down. Okay? If it's a positive A, it's opening up. If it's a negative A, it's opening down. And we're going to see this A value repeatedly. Okay, we're going to see this A value repeatedly throughout the quadratic equation unit. Okay, I think that's pretty much what we can tell on the surface, but we can tell something more by digging a little bit deeper. Earlier, we talked about the axis of symmetry, right? And we say, hey, you know where the axis of symmetry is? If you know the two roots, it's always the midpoint between the two roots. And the midpoint, it's found by, let me just go ahead and add the two roots to get together and divide it by 2, like how to find average. Okay, so that's the axis of symmetry. And if you know the axis of symmetry, then you can also know the vertex indirectly, of course, because the vertex is going to be the x value from the axis of symmetry. So you know that. And then you can go ahead and plug in to equation to find out, plug in the x value that you got earlier from the vertex, and then you can find it out. So that's just like what we did earlier. All right. And then we say, huh, yeah. And you can also tell the y-intercept, you can actually find out the y-intercept. And to do that, remember that y-intercept, it's always 0 comma something, right? So you can simply plug in 0 for x. Okay, so you have just negative R1 and then negative R2, and then you can just go ahead and calculate it. Okay, so it's just A and then R1 times R2. Okay, done. Done. Okay, so that's how you can get it. Just put in 0 for x, and you can get it. So the root form, it tells us some good information. And I'm saying this for this course, and I'm also saying this in the context of college admission tests like SAT and ACT. It's a good chunk of material in these tests, and we expect students to know, like, if you are given the root form, or just like the previous problem, if you're given the standard form, and could you change it to the root form? Could you do that change without being prompted? Okay, that's a key thing right there. Okay, so that's the root form, and the next video we will go ahead and start investigating more into the standard form. All right.